Okay, so I wanted to show how to fix processes when placing screws so that you can control the depth of the screw, the drilling depth of the screws. You can see here, I pulled this one out of TopSolid's um, uh, hexagon socket head cap screw family and placed it in and did the standard process for it. And you can see the hole it drilled went right through the part. And over here, you can see I was able to make it so that it didn't go through the part. One of the weaknesses I think of the processes is it doesn't give you full control over the hole drilling and the tapping of the hole. There's some pre-defined parameters that are set by the by the threading standard that is being used, and some other tricky. So this is how this works. Let me go ahead and delete both of these, and we can just do this over again so you can see. So here I'm in the TopSolid ANSI library, and I found the family of screws, of socket head screws that I want to bring over. So I drag, whoops, I got both those, I just wanted one. Alright, so we drag it into the assembly, and it takes a minute, has to think. Now, good. Alright, see, I've done this enough, I've got the timing pretty good. Alright, we're going to put a frame here on this point. Just got to invert it so the screw goes in the right direction. And I'm going to do a 1/2-13 2-inch screw. Alright, and then we're going to go do the process. Basically, we need to select the components of the assembly that's going to get certain operations. So this is going to be a clearance hole. The tapped hole goes into the bottom piece here. Facing is the top piece. This is the top piece. Clearance hole is the top piece as well. So then we go ahead and click OK or validate the green check mark. It takes a minute for it to think. Alright, and as you can see, it puts a hole where I don't want it. And the problem is this parameter here drives the length of the thread, but it doesn't change the length of the hole with respect to the thread. If I make this shorter, yeah, I can make the thread shorter. I think I can make the hole so it doesn't go all the way through, but it doesn't give you enough thread to grip onto. So what do you do about this? Well, the first thing that I did was I copied the family and the parent into my own library. So I got a fastener folder here, and I made a copy directly from TopSolid. Then one of the other things that I did too is I have my own sort of mechanical library where I've made a copy of the threadings that come from TopSolid, the threading libraries. And I believe, I don't think they're not in ANSI Mechanical. I believe they're in TopSolid Mechanical. And if you go to, let's see, you got drillings. It's in, yeah, there's a folder called Threadings, and all the threading documents are located here. And I'll open up the one in my library so you can see what goes on. But what I did was I wanted threadings that would give me the closest standard drill diameter that would give me as close to a 70% thread engagement. And there was a calculator that I used to come up with the drilling diameters, and I made changes that differ so I could get like 70%. And it kind of helped with tool life and some other stuff. Well, one of the parameters is a thing called drilling extra length. And so for the 1/2-13, I changed it to a 0.2 in my library, or in my threading document, threading standard. Now the next thing that you do then is after you, don't forget I had you copy the family documents for the cap screw into your own library. So you need to copy the parent and the family. Let's close this. I don't know where that error came from. Let's just close that document. Let's open this. So if you open up that document and you go to the provided function for the screw, one of the choices that you have is you can specify the threading standard. And so all of the threading standards from the TopSolid library, whatever libraries you have referenced up here in the reference, they show up in this list. And so we're going to go to the, yeah, and see I have form taps. I've created my own form tap libraries as well as the cut tap library. So let's just go to threading. Well, shoot, I don't remember what library I modified. Give me a second. Oh, so I just modified the inch ISO 72570. So let's just go back and just change it to that one. ISO 725, 70%. Where did it go? There it is. It's right there. All right, so this is the library that I modified. So you have to modify the function for the parent of the screw family for this guy so it has the right one. And I already modified it, so I'm just going to undo this checkout, undo changes so it goes back to where it was before. Okay, so now you're ready to place it. I believe that's all the steps that you need. Let's go back to our library here, and let's grab this family, bring it over. Okay, this will take a minute. So we're going to do the same thing we did here. We're going to create a frame so we can put it on this curved surface, reverse direction, and put that in, and then let's select the half 13 2. I'll show that in a second. Processes should come up automatically. If it doesn't, I got some clues from Mr. Bill on where that needs to be changed. Okay, so clearance hole. This, we've got to click down in this box. This is where the clearance hole goes. The tapped hole goes down here. We want this to have the facing, the vertical countersink, and the clearance hole, and we just press validate, and boom, as you can see there, it gives you the screw with the hole over the drilling over depth that we specified in our custom threadings documents.